This is an interesting one. We've got a particle of mass 4 kilograms that's constrained to move along the x-axis under a single force that's proportional to its position cubed. The particle's speed at point A is 6 meters per second, and we want to know its speed at point B, where our position is -2 meters. All right, how do we do this? I'll start off by restating this. My force is equal to -8x cubed. This is interesting. We can deal with this, actually. I'm going to write down a bunch of other stuff I know. XA from the problem statement was 1 meter. VA that goes along with that was 6 meters per second. We also had XB of -2 meters. And we had VB, which is what we're trying to find. What else do we have? Mass, 4 kilograms. Those are all the things we know. Now we want to know, what is the speed? I can do a conservation of energy statement. Or I could do a work energy principle statement. Either way, we can say whatever energy we start with, plus the work that's done to get from A to B is equal to the total energy we end with. The energy we start with is 1/2 mVA squared, plus we don't know the work yet, so we need to figure out that work, and then that gives us, so plus something is equal to 1/2 mVB squared. Let's try and figure out that work. We'll use the definition of work to try and figure out this work. Well, work is defined as the integral of f dot dr. So to get from A to B, we'll integrate from A to B of -8x cubed with respect to x. We can do this. We add 1 to the exponent, divide by the result. So we get -8x to the 4th over 4, evaluated from xa to xb. And I could have actually plugged in numbers here. Maybe we should have. Let's do that right now. Xa is 1, xb is -2. So when evaluating this, we get -2 x to the 4th gives us -2 to the 4th minus 1 to the 4th. That looks right. We get 2 to the 4th is 2 times 2 is 4. 4 times 4 is 16. Minus 1. So that's 15 times -2 gives us a -30. So I get -30 joules, which is that work to go from A to B. I can plug that in over here now and solve for this in terms of the other things that I know. I'll leave this like that so that I can just solve for VB by multiplying by 2, dividing by m, taking the square root. To be clear, we're solving for VB. So we get VB is equal to plus or minus the square root of 2 over m times 1/2 mVA squared plus the work to go from A to B, which is that -30 we just found. Plug all that in and you get a final velocity of plus or minus 4.58 meters per second. Now the question that you might ask yourself is, well, which is it? Is it plus or is it minus? We were going 6 meters per second at point A, and then we were feeling a force that was pushing us back. So if we're going, let's say A is right and left. If I'm going to the right at 1, I have to turn around somehow. And when I get back to -2, I'm probably going negative. So I would probably default to calling this a negative, but you can try and plot this and see if you get any additional insight from that as well.